Good evening, sir.
Good evening, sir.
Guys,
Good
how are
evening,
ya?
sir.
Good evening, sir.
Good evening, sir.
Hello. Good to see everybody. How is everyone?
Fine, sir. How about
Fine,
you?
sir.
Fine,
How about you, sir?
Awesome, awesome, awesome. I'm doing pretty well. Alrighty. So, this week we'll do one more week of revision, and then next week we'll have the quiz and the tests. Okay, guys. So remember last week we started the revision, so we'll continue that this week. Cover off more of the points that were missed in previous Kahoots, and then next week is when we will have the test, which is covering all of the content that we've been able to go through over the last couple of months. Now, last week's homework, I only had a response from Ritishan, so thank you for that, Ritishan. Nobody else sent anything to me, so I'm gonna assume that we're all gonna get 100% in the Kahoot and the test coming up, because the question was to highlight something that you wanted to learn or an area that you needed more understanding on. I haven't heard from anyone except for Ritishan, so everybody's yeah, good to go there.
I,
Your hand up, Sarin, yes?
yes, sir. I didn't hear when you said about the homework, sir.
Okay. That's all
I
right.
got some internet problem.
No worries. That's okay. Look, I'll always if you guys ever get confused about the homework, I always put it in the slide deck as well. Okay? So after the class, make sure you open the slide deck and scroll towards the end. And it's generally on the last or second last slide. Cool?
Okay, sir. See it always, sir.
Thank you. All right. So the only question requested was how do rocks melt? So there's a lot of information on this slide, but I'll try to go through it at a high level for you guys. So in terms of rocks melting, okay, so how do rocks melt? Now, the transformation of rocks from a solid into a molten or a liquid state takes place through melting. So we were talking about different states of matter and the various processes. Remember, we saw freezing, melting, sublimation, deposition, all of those. So in this scenario, we're referring to the melting phase. And for it to take place, it requires high temperatures. And in some scenarios, pressure. So in terms of temperature, that's the primary factor which causes rocks to melt. So most rocks themselves are composed of minerals, and each mineral has a specific melting point. As the temperature rises and these minerals hit those melting points, they begin to break down and melt the actual rock. Now, the creation of heat and the transfer of that heat can happen in various ways. So one of those is magma rising from within the earth. It could also be external sources like volcanic eruptions or even human activities that create heat, which then transfer down to the rock, impacting the minerals. When those minerals hit their melting point, that's when the rocks begin to melt themselves. Now, magma, which is a molten mixture within the earth, is something that can also create that impact and start melting the rocks themselves. So that's from inside the earth itself. And then pressure is the last point, which can impact the melting of rocks in two ways. So one is where it increases the temperature required for melting rocks. So rocks at deeper levels, right, they need a higher level of pressure. They experience a higher level of pressure, which means they need more heat to melt. And on the flip side of it, it lowers the melting point of rocks as they rise to shallower areas. So as rocks move up towards low pressure zones, their melting point decreases, which causes them to melt. So deeper levels, higher pressure, higher heat. Shallower areas, lower pressure, melting point decreases, which requires less heat. How does that sound for everybody? I know there's a lot in there, but as I said, you can read through it, and it'll be in the slide deck for this week as well. Ritishan, I might just point to you since you brought up the question. How did you go with that one?
I understand, sir.
Okay, perfect.
And I want to know is something true. Like
yes,
they will place a gigantic glass in front of a rock. Then when the sunlight hits the the gigantic glass, it changes into a triangular light thing and hits the rock. That makes the rock heat up and melt. Am I right, sir?
Mm-hmm. Absolutely. So what you're referring to is that the glass piece is the one that goes on an angle, right? It's on like a little wooden thing, and the glass moves in an angle.
Yes, sir.
Yeah. Okay. So what that's basically doing, as you said, it's taking the sunlight, it's trapping the sunlight, and then magnifying it in a very specific and very specific point. And so when that point is hitting the rock, it's then getting in contact with the minerals within the rock. The minerals hit their melting point, which then causes the rock to either crack, melt, and have those changes. So exactly right. Exactly right. Cool.
And I'll tell one fun fact, sir.
Yeah, go
about
for it.
The light. I'll tell something about the light. How to measure the speed of the light? It's pretty simple to measure the speed of the light. If you have a laser point and a piece of glass, one piece of glass and a mirror and a gear which can spin smoothly, which has 720 teeth, and when you point, and you must place the glass like the laser point can shoot there and can go into the hole of the gear, then hit the mirror and come to the glass piece again, and it will reflect to our eyes, right?
Yes.
And when the laser point goes there and tries to come back, when you spin the gear very fast, the light won't appear again to existence.
Yeah, exactly.
Because the gear is spinning very fast that the light is completely blocked.
Bang. Yes. Correct. Where did you see that one? How did you learn about that?
In the YouTube, sir.
YouTube. Love it.
I was trying to study physics and I find this out.
Nice. That's a good one. And was the video with like graphics? Did they show the process, the experiment? Were they able to show the experiment?
It's just animation, sir.
Animation. Okay. Cool. That's good. Alrighty. So let's go on to and begin with the presentation. So Satvika, if you would like to kick us off for today.
Yes, sir. Hello everyone, I am Satvika. I am presenting about what happens if moon comes too close to Earth. This is a theory. If the moon comes too close to Earth and breaks the limits 9,500 kilometers, Earth's gravitation cool will cause it to crumble, resulting in the formation of rings around the planet. There will be no moon to look at as it crumbles. The bright side, we will have stunning rings in the sky. Thank you, everyone. This presentation has ended.
Thank you, Satvika. You zoomed past that presentation as fast as you could. No, well done, well done. Can everyone jump off mute? Give her a round of applause. Well done, well done. All right. Sarwin, you're up next.
Yes, sir. My name is Sarvi. My presentation is about nuclear bomb. Nuclear bomb are powerful weapons that use nuclear reaction as a source of explosive energy. Scientists first developed nuclear weapon technology during World War II. At the end of World War II, atomic bombs were used twice against Japan at Hiroshima and Nagasaki. A period of proliferation followed the war during the Cold War, when the United States and the Soviet Union competed for supremacy in the global nuclear arms race. The Manhattan Project was the U.S. lead effort of working atomic bomb during World War II. The Manhattan Project was to initiate response to fears that German scientists had been developing a weapon using nuclear weapon since the 1930 on December 28, 1942. President Franklin D. Roosevelt authorized the Manhattan Project and for various scientists and military officials to be working on nuclear research. And if a bomb explodes, the wave go far and the people close to it, they will die. And it will take oxygen away and release carbon dioxide, so that many people will die. And my conclusion is that of this, many people will die and living things will destroy living things. Water won't come and we won't make farming, and at the end everything will die. And this is my conclusion. Thank you.
Thank you, Sarwin. Fantastic. Everyone back off mute. Give him a round of applause. All right. Well done. Thank you, Sarwin. Thank you. All right. And now, Ritishan.
Okay, sir. Hello, everyone. My name is Ritishan. Today my presentation is about light bulbs. Back in the days before light bulbs was invented, use of candles were quite common in households. In fact, they were used even today when we experience a blackout. But candles can be very, very messy. Though candles are beautiful to look at, they can be very dangerous. And that is why we need to thank Thomas Alva Edison for inventing the first ever light bulb that have since enlightened the world. Thomas Edison is the inventor of the light bulb. Is also known to have developed more than 1,000 other inventions apart from the light bulb. Some of his famous inventions include the voting machine, electric battery, and the movie camera. Thomas Edison wasn't a bright student. He found it to be a painful, dull routine to go to school. However, he had a very curious mind and was always inclusive to conduct science experiments under the tutelage of his mother. It was his inclusive nature that led Edison to illuminate our homes. Edison experimented with different kinds of filament to find the perfect one. After trying out many options, the carbon filament was the winner. Before he could declare his bulb, he had to put it on test and see if it was long-lasting. on 22nd October 1879, and it burns for 13.5 hours, so it was a success. This is my presentation for today.
Thank you, Ritishan. Thank you. Everybody, round of applause again. Alrighty. Cool. Thank you. All right. Well done to everybody who did their presentation today. Thank you. Appreciate it. I hope you guys had some fun putting those together. Next week, I think we have our last 3 teammates to do their first presentation, and then we'll change it up a little bit going forward, where instead of just choosing a random topic, we will do things focused on the content we're actually covering. So maybe we'll do one on each type of chapter or something like that, which is a little bit more centered around the science content. But I wanted to do the first lot just so you guys get a little bit more comfortable and get into the process of presenting itself. So thank you for that. Alrighty, so let's jump into it. So going back a few weeks, we spoke about sound. So again, I mentioned it to you last week. The things that I'm covering in the revision classes are the questions in the Kahoot where multiple people got the answers wrong, right? So the intention behind this is that potentially there's a gap in the understanding. We'll cover those gaps, and fingers crossed, when it comes to test time, everybody's clear, they understand the content, and all the questions are done correctly. So let's start. Now, what type of energy is sound? Who remembers this one? So just remember, if you know the answer, put your hand up on Zoom. I'll call out your name.
Sarwin, sir.
Yes, Sarwin, but just hold on. Put your hand up on Zoom for me first, okay? So, Sarwin, yes, tell me.
Sound is a type of energy. Its name is kinetic energy.
Perfect. Kinetic energy. And do you know what the kinetic energy refers to? How would you explain kinetic energy?
What, sir?
Do you know how you would describe kinetic energy?
Not really, sir.
That's okay, no problem. Does anybody else want to have a go at how you would describe kinetic energy? Dinishan, I see your hand up.
Kinetic energy means that is moving, right, sir? That is moving.
Exactly. It refers, yes, correct. It's energy because it's energy from the result of motion and movement. Yes. Well done, Dinishan. Now, does anybody remember how we can increase the volume of sound? Sashwin, I see your hand up. I don't know if that was one from the question before or whether it's for this one.
The first one, sir.
No worries, mate. If you can just pop your hand off for me on Zoom. Sarwin, Sashwin, Dinishan, I see your hand. So if you can just pop it down for me. Ritishan, yes.
We need to amplify it, sir.
Yep, absolutely. That's definitely one way of doing it. Amplify. And was there a second one, you know?
Yes, sir.
Yeah.
If it's a drum or something else, we must bang it harder.
Yes. So putting more energy into the action, right? So as you said, the drum is a perfect example. Yeah, go ahead.
Or if it's something like a flute or something we need to use air, we must put on more air. Also, it's you can also say we must need more energy.
Yes, exactly. So more air, hitting it harder, all of that, you're exerting more energy into what you're doing, right? So that will increase the sound volume of sound, exactly. And then the second thing you said, or the first thing, sorry, you said was amplifying it, right? And the example there is in a guitar, you have the little box behind the strings that holds the air, increases the amount of air behind it, which then vibrates and amplifies the sound. Sarwin, I see your hand up. Do you have a question or something to add?
Yes, sir. I have a question that.
Yeah.
You mean the box behind the strings, right?
Yes. So you know on the guitar you have the little hole and then. Yeah.
Yes, sir. Like strings and a hole in it. You are meaning that one, right, sir?
Correct. Cool. Ritishan, your hand's still up. You want to say something?
No, sir.
Okay, no worries. Cool. Now, does anybody remember how we can vary the pitch of sound? So we just covered the volume. Who remembers pitch?
I know, sir. I know.
Hold on, guys. Hold on. Remember, please put your hand up on Zoom. You don't. I can see them. So I'll call your name out when it's your turn. Okay. Takshaya, yes.
Longer keys and closer skin produce lower notes.
Yes, perfect. So, oops, sorry. Yep, you said longer and thickness of strings. Did I hear you right?
Sorry, sir?
Sorry, you were talking about strings, right? You said the longer keys or strings?
Looser skins.
Yep, perfect. And was there any other ways we can vary the pitch of sound? Thank you, Dakshaya. Oh, you've got more? Yeah, go for it.
Shorter keys and tighter skin produce higher notes.
Yep, skins, absolutely. Tightness of skins. And I gave away the middle one because I had to go through it in order, but it's the length of tubes, right? So you can see on this picture, for example, each one of these will have a different pitch because the length of their tube actually varies. Now, before I move on to plants, anyone would like to say anything or have any questions regarding sound?
Nothing, sir.
Sorry, go ahead. What was that? Oh, no, nothing.
Nothing,
okay, cool.
sir.
Perfect. No problem. Alrighty. So plants. Now, all plants do something very special, which is make their own food. As humans, as animals, we can't make our own food, but plants do. Dinishan, what is this process called?
Synthesis. Photosynthesis.
Perfect. Now, who remembers what the word photosynthesis is broken into? There's
I know,
two
sir.
parts to it. Hold on.
I know,
Just
sir.
put your hand up, Sarin. Hand up only, please. Yes, Sarin, tell me. What is it broken up into?
Photo means meaning lightning, sir.
Light,
Synthesis
not lightning, light.
Light.
Yeah?
Light, sir.
Yes?
Synthesis means building or putting together.
Perfect. Now, plants capture energy from sunlight and store it in the sugars and the starch that they produce. These are then used to feed the plant itself. Who can tell me where this process of photosynthesis takes place on a plant?
Can Jasmine tell, sir? I haven't tell.
I know. Just give me 1 second. Loka?
Leaves.
Leaves. Exactly. So the green parts of the plant. So the leaves is a very good example. Sorry. Now, what is the green pigment in leaves called? Sashwin.
What is the question, sir?
So photosynthesis takes place in the green parts of the plant, so things like leaves, Do you know what the pigment that creates that green color is called? It's okay if you don't. I just saw the hand up. Sorry.
I know, sir. I know, sir.
Hold on,
Is
Sarwin.
it?
Please stay on mute.
Is there?
Yes.
It starts with C, sir. The letter C.
Correct. Exactly right. It does start with C. Yes.
It's,
Would you like to phone a
Try-
friend?
the child.
It is a CH.
CHNIOR.
Close, close. It's an L. Let me.
I don't remember the full one, sir.
That's okay. Not a problem at all. Ritishan, do you know the answer?
I know, sir, but I can't pronounce it correctly. May I spell it?
You can. What I might do before you spell it, I can see Dakshaya wants to say something as well. Let me just go to her and I'll come back to you. Dakshaya, yes?
Yes. CHLOROPHYLL.
Yes, correct. So,
Yes, sir, that was my answer too.
Perfect. Thank you, Ritishan. Which is chlorophyll. Which is that one there. Exactly. Now, roots, flowers, fruits, and seeds, they can't make food. They have different functions. So, as we said, the leaves and the green parts of the plant create food through photosynthesis. The other parts of the plant have different functions. Now, who knows the 4 key components for photosynthesis? Sarwin?
Light, chlorophyll, and carbon dioxide, and water, sir.
Yes, correct. Does anybody remember the formula for it? So what's on the left-hand side and what's on the right-hand side?
I know it too, sir.
That's okay. Just hang on for me. I'll call your name up. All right, Ritishan, yes.
Okay, sir.
Sir, I have just came, sir.
As Sarwin said, we need light plus chlorophyll plus water plus carbon dioxide equals starch and oxygen.
Bang on. Correct. Well done. You guys are smashing these. All right. Good to hear. Now, diving into the flowers, which is another part of the plant, who can tell me why they exist?
Can Sashwin tell, sir?
Sashwin, I'll call on you. Just stay on mute for me, okay? Stay on mute. Just put your hand up on Zoom, and I promise you I will call your name. Okay, Sashwin, go for it.
They do reproduction, sir.
Correct. Reproduction. Exactly. Now, reproduction occurs, as we've covered, when the pollen and the ova brought together and fuse. What is the term given to this process where the fusion of the two cells occur?
I know, sir.
Hold on, just stay on mute for me, Sasha. And if you're going to keep calling out, I won't be saying your name to answer, okay? I've mentioned it to you guys before. Put your hand up on Zoom. I will say your name, and then you give the answer, okay? Go for it, Sashwin. What's the answer for this one? Sashwin, you there? Yeah. No? Satvika, you want to give this one a go?
Yes, sir. It's over. And
So the answer.
Yep, you're back.
Sir, yes, sir. It's anther and the sigma.
Not so much. It was more around the process.
sir.
So the
I
term.
know. I know,
Okay, yep,
sir.
yep.
Is it?
I'll come to you
It
guys.
is-
I'll come to you. Hold on. Hold on. Stay on mute for me. Let me just give me 1 second. Satvika, yes?
Is it over and over?
No, so you guys are thinking about the different parts of the flower. So let me just rephrase the
Sir, I know.
question. Hold on. Mute, and I'll come to you. I promise. Just keep your hand up on Zoom for me. I can see the ones with the hand up, okay? Now, the question was referring to, so the pollen and the ova, which are the two sex cells, they're brought together and they fuse. The process of that fusion is called what, Ritishan?
Fertilization.
Fertilization. Exactly. Thank you. Now, the result of fertilization is a seed, and each of these seeds then become new plants. The process of moving pollen from the anthers to the stigma is called pollination, right? So we're moving the pollen from the anthers, right, which is the male organ, into the stigma, which is the female organ. That process is referred to as pollination. Now, another phase that we've spoken about is germination, which is where a seed becomes a seedling. Who could outline for me, and you've given me this answer for the previous question, what are the main parts of the male reproductive organs? I'll go with Sarwin.
Anther and filament, sir.
Bang.
They
Perfect.
and these are the important things, the male things, sir.
Yep. Perfect. Thank you for that one.
It is also pollen grains.
Pollen grains. So they, I believe, are yes, they're part of it. So, sorry. So the pollen grains are part of the process, absolutely. But if we were to say the two parts of the male organ, I would say anther and filament. But definitely pollen grains are part of the male side of the reproductive system. Definitely. Who can tell me what the main parts of the female reproductive organs are? Loka.
Stigma, style, ovaria, ovum.
Perfect. Exactly. And similar to Ritishan's point previously, it's the ova, which is part of the female reproductive side. But if we're talking about the actual parts of the organ, as you said, those 4 sections there. Now, when plants produce a seed, it is not growing. It's dormant, right? It's only when the seed is germinating is that it becomes active. Seeds don't need to produce their own food because when the seed is created, it's created with food stored inside it. Now, the limitation here, though, is that the food that's stored within the seed is dry. It can't move around, and therefore it can't be used by the seed to germinate and become active. Water is required to dissolve that structure and the food to allow the seed to consume. Now, sorry, before I move on, anything else, any questions with regards to plants?
Dinishan, sir.
Dinishan, yes, tell me.
It's EMBROY.
Embryo. Okay, so in a seed, right, you will have different sections. One section is the solid food. Once water is attracted to it and it comes together, the food becomes a solution. The solution then travels down to the dormant embryo. So when we say dormant, it means it's not active, it's not growing. So the inactive embryo, which is the initial part of the seed which comes to life.
Okay, sir, I got it.
Cool. Anybody else? Any questions? I see a couple of hands up. So Sarwin, I'll go to you. Yes?
Yes, I didn't understand, sir.
You didn't understand which part? The embryo part? Or a different section?
The how about food stored in the seed? So that one, sir.
Yep. So now, so inside a seed, right? The seed. So okay, let me take a step back. So seeds in general can't produce their own food. So remember we were saying in the plants, there's only the green part of the plant which can produce which can take place for photosynthesis. So the seeds are not part of the green sections of the plant, so they can't produce their own food. For them to survive, they already have food stored within them, but the food is not stored as a liquid solution. It's stored as a dry, solid section. Now, for the seed to be able to take that dry piece and convert it and make it something that it can consume, it needs water. Once the water and the dry food combine, it becomes a solution. That solution then travels down to the embryo, which is the initial part, which then blooms, becomes a seedling, and grows into a plant. Does that help?
Yes, sir.
Okay, cool. Now, light. Some materials allow a lot of light to pass through them. For example, you can see the glass on the bottom left. Loka, what is this type of material called?
Transparent.
Perfect. It means we can see objects clearly on the other side when the material is transparent. Other materials allow some light to pass through. For example, the ice cubes, where they're a little bit cloudy, so you can see through them, but you can't see them clearly. Ritishan, what's this one called?
Transclusive.
Translucent. Close. Very close. Translucent. So this is where we can still see through the object. However, due to its shape and conditions, it changes the way we perceive light and therefore how we see objects on the other side. Now, the last group is where the material does not allow any light to pass through. What are these called? Who knows the answer?
Sashmi, no, sir. Sashmi.
Sashwin, remember? What did I say before?
And I just forget, sir. I just came right now. My phone is just carrying off.
Okay, no problem. That's okay. But tell me, what should we be doing?
Were you talking about the thing that doesn't give light to pass it?
Yeah.
The thing is, can I tell, sir?
Yep.
It is called opaque.
Correct. Opaque, exactly. That's where the light does not pass through at all. So in the example of the rock on the bottom right, you won't be able to see what's behind it because it doesn't let any light to pass through.
So
Now-
Ritishan wants to ask one question, sir.
Yes, go ahead, Ritishan.
Can you take a little, in this picture, there's 3 pictures, right? The third one, is it cement or rock?
The photo is of a rock, but cement would have the exact same qualities, where it's also opaque.
Okay, so it looks kind of weird like a cement. That's why I
It
asked.
does. It does. Look, it could be a chunk broken off a block of cement. When I was searching it up on Google, I just typed in rock, so that's what came up. So I assume it's a photo of a rock. But yeah, it certainly does look like it could be cement as well. Like if you had a block and you chipped at it, it would look like that. Cool?
Okay, sir. Thank you.
No worries. Sarwin, you have a question? No? Cool.
No, sir.
Now, the front of the eye is covered by
I know, sir.
certain something. Hold on, guys. I didn't hear who that was, but please stay on mute, okay? Put your hand up when you're ready, and I will call your name. The front of the eye is covered by something. It bulges slightly, and it is clear. Satvika, what's that one called?
Pupil.
Ooh, not pupil. It's I'll give you a bit of a hint. It's a clear part of the eye. So it's not the black one, it's clear. Loka, do you know which one it is? Just give me 1 second. Sorry, I can't hear very well. Ritishan, could you pop yourself on mute for me? Thank you. Sorry, Loka, go ahead.
Yes, sir.
What was the front part of the eye that bulges slightly? What was the answer?
Yes, sir.
Not the iris. No, close. It's not, because the iris is still the colored part of the eye, right? So if you look into someone in front of you, you'll notice that they might have a blue, green, brown. Cornea. Yes, that's the one. Cornea is the front part of the eye. It bulges slightly. So if we look at the diagram here, it's this section here. That's the clear one. Okay. What does the cornea do? I'll go.
Ritishan knows, sir. I know.
Ritishan, I know. But remember, just stay on mute for me, because I want to give everybody in the class a turn, right? So there's a few people that are putting their hands up. I just want to go around, make sure everyone can have a go. Puvarna, yes.
To cover our eyes, to protect from the dirty bacteria.
Perfect. It definitely is a part of protection. Absolutely. Thank you for that. Takshaya, do you have another one to add?
Focus.
Sorry, you broke up just a little bit there. It provides what, sorry?
Help our eyes to focus.
Oh, I can't hear very well, Takshaya. Do you have a microphone you can bring closer?
Help your eyes focus.
To focus. Okay, so it allows the light to pass through to the eye, the internal part of the eye, to the pupil, which then allows the focus. So the cornea itself is that clear part which allows the light to pass through, which then hits the pupil, which then creates the focus. Now, what is the pupil? So you guys mentioned this one previously when we were talking about the front of the eye, but it's basically the black hole, right? So we can see on the diagram here, it's the black hole. It's a circular section of the eye in this part here. Now, the size of the pupil varies depending on the amount or the intensity of light arriving at the eye. On the next slide, there's a question about how the intensity of light impacts the size of the pupil. So just have a think about that. and it's on the next slide, okay? But before we jump to that one, just a basic question, the iris. Again, we answered it while we were discussing other parts. Sarwin, just stay on mute for me. So we discussed it while we were talking about the cornea previously. So the iris, Ritishan, what's the iris?
The iris is a very small muscle which can contract and relax when the light. It contracts when the light is very dark, and it relaxes when the light's intensity is high.
Yep, perfect. So you've answered two questions for me there in one. So you've answered what is the iris and then a little bit about the second slide as well. So it's the colored ring, right? So it's the muscle that you were talking about there outside the pupil. And what that allows is for this bit here that we were just discussing. So when there's a high amount of light, the iris relaxes, the muscle relaxes, and the pupil becomes smaller. When there's a low amount of light, the iris contracts. It makes the pupil become larger to allow for more light to enter the eye. Now, the distance... Yes, Dinishan, question. Go ahead.
Can you say to me again what is iris?
Absolutely. So, iris is this part of the eye. See the blue ring around the pupil? So the middle black part is the pupil. Then around it, you have the iris.
Okay.
Yeah?
Oh.
So the iris is a muscle which contracts and relaxes depending on the amount of light that's entering the eye. So in the scenario where there's a heavy amount of light and the intensity of that light is strong, the iris relaxes, doesn't need to do much work. The pupil becomes smaller, right? Because there's sufficient light around us. In the event that it's a dark environment, nighttime, there's not much light, the iris contracts, the pupil becomes larger to allow maximum amount of light to pass through the eye. How's that, Dinishan? Does that make sense?
Yes, sir, that makes sense. I understand it.
Good. Now, the distance of light does not impact the size of the shadows created. The size of the shadows are more impacted by the angle of the light source. Who can tell me how the angle affects the size of a shadow? The angle of light affects the size of a shadow. Sarwin, yes.
What, sir? Can you explain me again?
Hold on. I'll come back to you. Sashwin, do you know the answer?
Yes, sir.
Yep. Go for it.
The lower the light source, the lower the small shadow.
Okay. Are you sure?
Yes, sir.
Almost.
No, sir.
The lower the light, it's actually the longer the shadow, the larger the shadow. Because if you think about it, if the light source is on top, the shadow that it's creating is almost nothing. But as it comes lower, the shadow extends out. So the lower the light source, the larger the shadow. And higher the light source, shorter the shadow. Okay? Does that make sense why, Sashwin?
Yes, sir. I just made one mistake.
That's okay. As long as you understand it now, it makes sense why that's the case.
Yes, sir.
Okay, perfect. Now, Earth and beyond. I'll just get you guys the ones. I can see a few hands up. If you don't have any questions, if you can just take them off Zoom for me. And then if you have an answer, put them up, okay? Now, what is a sphere? Sashwin?
A spherical if it's a point in a Earth, the every side has to be equal as the point of it.
Correct. So from the center, right, the points on the surface need to be equidistant. Now, each planet travels around the sun in a pathway. What is that pathway called? Ritishan. Orbit. Exactly right. Now, the name of the journey we give roughly in a circular orbit, what is that one? Sashwin.
Solar system.
Oh, no, not really. So, hold on, Sarwin. What did I say? Please stay on mute until I call your name, okay? So, the question, sorry, Sashwin, I'll just rephrase it. So, we just said that each planet travels around the sun in a pathway. The pathway is called an orbit. Now, as you complete the orbit, right, as you complete that pathway, we give a term. Loka, do you know what that term is? Loka, you there?
Sun.
Go again for me, sorry.
Sun, sir.
Sun. So it's traveling around the sun. We give it a name. I'll go back to Ritishan.
Sashwin, I think I know this answer again.
I'll come to you, Sashwin. Hold on. Ritishan.
It's a revolution, sir.
Revolution. Correct. Sashwin, is that what you were going to say? Revolution?
Yes, sir.
Perfect. All right. Good. Now, the Earth itself is moving in two ways at the same time. One is the revolution we just talked about around the sun. So in the solar system, the pathway is the orbit. And as the Earth travels in that orbit and goes around the sun, that's called the revolution. The second way it's moving is called a rotation. So you can see on this diagram here, as the Earth rotates on this axis, so not around the sun, just around itself, right? It's rotating. That's the second type of movement. Now,
when the
yes, Sashwin?
Yes, sir. If the sun was in the middle, like here, if the Earth is revolving and at the same time it's rotating, it means the Earth is rotating, and at the same time the Earth is revolving around the sun, right, sir?
It is correct. So before I move on, actually, on that point, maybe Sashwin, you might know the answer. So if we say one rotation, how do we equate that in time? Ritishan?
It is 24. What? I don't understand, sir. Can you?
You're right. It's a day. Correct. So how do we equate one rotation in terms of time? I know it's not exactly 24 hours, but for the purpose of this exercise, you're right. We'll say it's a day. What about...
I know, sir.
Hold on. Stay on mute, guys, while I'm talking.
It is 23.53 hours, sir.
Yeah, 23 and a bit. Correct. Just under 24. 23 and I can't remember the exact time. I think you're right. Around 53. Now, a revolution. How do we equate that one in time? Sashwin, hand up. Hold on, Ritishan. Sorry, I'll call your name. Give me a sec. Sashwin, I see your hand up. What's a revolution equate to?
I don't know, sir.
Okay.
I remember it's a long one.
Yep, it is. Just a reminder, guys, if you don't have an answer or a question, if you can take the hand off on Zoom for me, because it blocks me from seeing the other people who have an answer. So if you don't have something to say, please remove the hand. Sarwin, what's the equivalent of a revolution in time?
What's the revolution?
A revolution, yep. If we're talking about that in time, what would we call that?
I think it's 24 hours.
No, 24 hours was for the rotation. I'll go to Loka. Loka, do you know the answer?
365 days.
Perfect. It's 1 year. Exactly. So 365, again, like the daytime, it's not exactly 365, but for the purpose of this exercise, we'll call it 365, which is about a year. So,
Sir, I know the exact time, sir.
Yeah, go for it. I'll take it off here.
It is 365.25.
25.
Yes.
Exactly right. Exactly. Now, the Earth sits on a tilted axis, right? So it's not perfectly straight. It's on a bit of an angle. So as it revolves around the sun, either the northern or the southern hemisphere will be tilted towards the sun. The hemisphere that's tilted towards the sun experiences more hours of sunlight and higher temperatures. So does that make sense for everyone, what I'm talking about? So if the sun is here, the Earth is not like this. It's actually like this, and it's rotating. So as it's rotating on an angle, there's always going to be one hemisphere. On this side, it will be north, but as it comes around, it then becomes the south, right? So one side of the world will always be experiencing more hours of sunlight and higher temperatures. This is what we refer to as summer, right? And that also explains why the northern hemisphere, when they have summer, the southern hemisphere has winter, and vice versa, right? So in the United Kingdom, the UK, England, winter happens in December, but in Australia, summer happens in December because they're on opposite sides of the Earth, and because it's on the tilted axis, not straight, as it travels around the sun, right? Each hemisphere has a different season. Now, any questions on this piece here?
Nope, sir. I have a
Good.
question, sir.
Darwin, yes, I see your hand. Go for it.
Can you tell me the southern and the north hemisphere, sir?
Yep. Okay. So I'm gonna grab let me just grab something here to try and explain it. So say we have okay. So say this box here is the Earth and my hand is the sun. Yeah. So the Earth doesn't stand like this. It's not like this in the universe. So because if it was, it means it would be rotating straight, and therefore the north and the south would always be equal in distance to the sun. The Earth is actually on an angle like this, which means one side is always closer to the sun as it rotates. Yeah? So when it's on this side of the sun, the northern hemisphere is closer, which means it's summer for the northern hemisphere, which is the top part of the Earth. As it does its revolution and comes to this side, because it's on an angle, you can see here, now the southern part is closer to the sun. Yeah? So in this case, it now becomes winter for everyone in the northern hemisphere, which is the top half of the Earth. So all the countries like the UK, US, Canada, it becomes winter. And for everyone on the bottom half, the southern hemisphere, countries like Australia, New Zealand, it becomes summer because now Australia is closer to the sun. Whereas at this side, the UK was closer to the sun. Does that make sense?
Oh, yes, sir. Thank you.
Perfect.
Makes sense.
Beautiful. Anybody else have any questions?
Sir, can I ask Dinesh?
Yes, go for it.
If Australia's summer is winter, UK summer is what, sir?
No, sorry. So we take a step back. So Australian summer happens in the months around December, and at the same time, the UK experiences winter because they're on the two sides of the earth. So UK is in the northern hemisphere, Australia is on the southern hemisphere. Right?
Okay.
So when Australia experiences summer, UK experiences winter, and the same thing happens in reverse. So when the UK is in summer, Australia is in winter.
I got it.
Perfect. Anybody else have any questions?
No, sir.
Okay, great. Now, as I was saying, guys, so next week we will do a bit of a test, right? So going through a number of things we've covered over the last few months. Now, I hope the last 2 weeks where we've done a little bit of revision has been helpful. But over the next few days, you should go through and study up on any areas that you still have gaps in, right? So make sure you go through all of the content. And you have our slide decks, you have the recordings. So go through those and get ready, prepare for the test, and we'll do one next week. Okay?
Sir, we in the test we do in Kahoot.
The test, we probably won't do it in Kahoot only because I would like to do a little bit more. Oh, sorry. Are you talking about the test or you're talking about today?
Test.
The test. Okay. With the test, I would like to do not only multiple choice, but also some short answer questions. So you can write out the answers. So we will do the test as a physical one where we do it on some paper, but then we'll get back to Kahoots the following week.
Okay, sir. Today we have test.
Not today, unfortunately. We're coming up to time. I can do it if you got. I have the Kahoot ready. It's the same one from last week because it's still revision, but I don't know. I don't think we have enough time.
Sir, can I talk a little bit?
Go for it.
If
Do you have a question?
next week we already finished the test and we can do a little bit today the Kahoot.
Yes, we can do the Kahoot next week. Is that what you're saying?
Yes, sir.
Yeah, definitely. Absolutely. So we can do this week's Kahoot next week as a revision as well. Definitely. Cool.
Cool, sir.
Anybody else have any questions?
Sir, who is
No, sir.
the next presentation, sir?
No, sir.
Sorry, I just had multiple people talking. If you can just put your hand up on Zoom for me, and then I can call your name out. Dinesh, yes, again, go for it.
Sir, the next presentation.
Yes, good question. Here we go. Prinsika, Dinesh, and Rahul. Okay. I don't think we had Rahul join the call, so I'll put a message into our chat just saying the three people's names as well. But yeah, hopefully. Yes.
Dinesh letter taught him, sir. Dinesh letter taught him.
Sorry, go again.
Later I told to Rahul, you are in a presentation.
Okay, perfect. Thank you. Thank you. Sashwin?
Nothing, sir. I was just supposed to tell Dinishan's what was Dinishan telling, so that's why I was just going to tell
Perfect.
yours to you.
Awesome. Thank you, guys. Yeah, if you can let him know, that would be really helpful. Thank you. Anybody else? Any questions?
No, sir.
No, sir.
Okay, no dramas. So that takes us right to 10 o'clock. Sorry we didn't get a chance to do the Kahoot this week, but I thought it was important that we get through all of the revision slides, right? Because we're doing the test next week. I didn't want to miss out on any of those. So hopefully the last 2 weeks have been helpful for any of you that had some gaps in the content there. Like I said, prepare for it. Go through the slide decks. Go through the recordings. And get yourselves ready for next week. Sashwin, yes, you got another question?
I learned the things that I don't know. I have just several things that I didn't know and I understood now.
Perfect. I'm so happy to hear that. That's really good. I'm glad.
Dinosaur only don't know the two things, sir.
Okay.
About the matters.
About the matters, which do you still have questions on them?
That's the sublimation, right? The sublimation.
Sublimation and deposition. Okay. They're in the slide deck as well. So have a read through, and if you still have any questions, let me know. Okay. But they're in the slide deck for you there in last week's one. Cool. I think that takes us to the end of the class. So thank you so much, everyone. It was good seeing all of you again. If you've got any questions, as always, please let me know.
Thank you, sir, for teaching
I
us.
have a question, sir.
Oh, sorry. Yes, Sarin, go ahead.
The test is next week, right, sir?
Yes.
Okay, sir.
Cool. No worries. Everybody else all good?
Yes, sir.
Yes, sir.
Perfect. No worries. Easy, guys. Have a good rest of the day, and I'll see you next week.
Okay, sir. Bye, sir.
See ya.
Bye, sir.
Bye.
Thank you, sir.
Okay,
Bye.
sir.
Bye.
Thank you, sir.
Thank you, sir. Bye.
See ya. Bye.